This is problem number 83, which is kind of similar to the previous problem. So we have given a linearly polarized sinusoidal EM wave moving in the positive x direction. Okay, so it has a wavelength of this much. So magnetic field, which is oscillating in xz plane, has the value of this Tesla. So obviously you have to convert that into standard SI units. So the magnitude of the electric field vector for this wave can be written as like E equals to E max sine kx minus E equals to obviously ext E max sine. So kx here is minus because the wave is moving in x direction, omega t. So for part A, you have to find out E max, which is kind of easy. CV max, this is C, B max is given, so this is the E max. For part B, the wave number K, which is again 2 pi over the wavelength, which is this, the wave number is this much. For part C, the angular frequency, omega, which is ck. Okay, you can take this, omega equals to 2 pi f, and you can write like omega equals to 2 pi f, f equals to c over lambda. 2 pi over lambda is k, so it will be ck. You can do that, you can take out that. So this is omega. For part D, we have to part D, the plane in which the electric field oscillates. Okay, we have to find out the plane in which the electric field is oscillates. So we know the Poynting vector is proportional to E cross B as S in x direction, B in xz plane. So obviously E must oscillate in y direction because this is a cross product. Okay, so E vibrates in xy plane. So for part E, so let's find out the average Poynting vector, that is as average equals to this. We have this formula 1 over 2 mu naught E max B max, where E max is CB max. Okay, and there will be 2 B max, so B max is square over this, and we have all the values given. So this is the average Poynting vector, obviously in I the along positive because S is in x direction. So for part F, so let's find out the radiation pressure. Perfect, we have given a perfect reflector, so for that we have the formula 2I over C. Okay, and you can use that it's as average for this. Okay, so we have all the values given. This will be the radiation pressure will be this amount of Pascal. For part G, the acceleration of solar cell of dimension this, of mass this. So we have the dimension this, means the area is the product of these two sides. The mass is, that is in grams, so you have to convert that in kg. So we have simple kinematic equation, that is F equals to ma, so A equals to F over m. Obviously force is the product of pressure and area, so we have both. So the acceleration will be like this. So this completes this problem.